As we know, in yesterday's class, we have seen what are the steps we are following for extraction of metals from their ores. So totally we are taking four different steps. The step number one, we are removing the impurities so that the concentration of the ore is increases. So that is the first thing. The concentration of the ore has to be increases. This concentration of the ore only we used to call it as what? Enrichment of. Yes, please, everybody. So enrichment of ore. So that is the first step which we will follow. So for based upon the metals, based upon the type of ore, a different process we will use it. And the second type of one which we are using, conversion of ore into what? Everybody? Yes. Yeah, conversion of ore into oxides. That is the second one. And the third one is conversion of oxide into what? By using a reduction process? Yes, all of. So conversion of oxide into metal by using a reduction process. So in this reduction, maybe some are self-reducting and some are chemical reduction and some are electrolytic reduction. So mainly chemical reduction. So self-reduction, no problem. Chemical reduction, we will use a material called as what? Everybody? Coke or coal. So basically that is what in the carbon forms. So carbon, we will use it as a reducing agent. So here basically we'll take it as a coke. And then the last one is, what is the last one, everybody? Refining of the metals. So for this refining is also based upon the metals, we will follow the different techniques. So the most popular technique is electrolytic method. So like generally for purifying silver, copper, gold, nickel, chromium, zinc, aluminum, lead, these all the metals can be undergoes mainly the method called as electrolytic method. So for this electrolytic method means immediately you have to remember two reactions. One is what reaction, everybody? One is one is cathodic reaction. Cathodic reaction. Another one is what? All of you. Another one is anodic reaction. So cathodic reaction means what will happen? First anodic reaction will write. Anodic reaction means metal atom will turns into metal ion by loss of electron or gain of electron. Everybody. Mr. Rohit, loss of electron. And then this metal ion will take electrons from the cathode and it will turns into pure metal atom. So this is what anodic and cathodic reaction. So this is very important in extracting many metals, like purifying the many metals, refining of the metals. So this anodic and cathodic reaction is very important. So according to the given metal, you have to replace this metal M with some that name of the element. Okay. So always where we'll get the pure metal, everybody? We'll get the pure metal at where? Cathode or anode? Yes. Cathode. Pure metal is always obtained at where? Mr. Rohit, are you there in meeting? Obtained at cathode. So that is what you have to remember. Is it clear, everybody? All of you? Yes. So till here we have been discussed in our last class. So there is other methods for different metals. Different metals we will use different things. Like as I said, some metals we can undergoes distillation. Some metals will goes like oxidation, and some metals we undergoes zone refining process. There is a different techniques for refining the different metals, liquefaction methods and all. But for us, class 10th, nothing we have, only electrolytic method we have. So this electrolytic method is only the very important one. For mainly, we'll use it for copper extraction. So that is alone you can remember. So the same diagram will modify also for every metal commonly. So this is what the 4 steps how we can extract the metal from their ore. Now in today's class we are going to see the most important concept is categorizes of extraction process depending upon the activity series. So for this activity series is again compulsory you should learn. So all of you keep heading. Categories of extraction. Depending upon what, everybody? Categories of extraction processes depending upon activity series. Understanding? Yes, please. So now I will give you the 3 points that based upon the 3 points only we undergoes even entire the exams process also wherever it will goes. The same thing it will be followed. So extraction of metals low in the activity series. Extraction of metals low in the activity series undergoes copper and as well as mercury. Extraction of metals middle in the activity series, so undergoes zinc and iron. Next, extraction of metals high up in the activity series. So what is that? Sodium, potassium, calcium, magnesium, and aluminum. So keep it in mind, these metals basically we used to call highly reactive metals, always exist in what state? Free state or combined state? Everybody. They always exist in combined state because they are highly reactive. So that is why they generally exist in oxides, like in form of oxide or halide ores. Next, zinc, and you can take it as a iron, and you can take it as a lead, you can take it as a Pb. Tin also. Sn means what, guys? Sn means what? Tin. Understanding? So tin. So these are moderately reactive metals. So generally we will find it in sulfide ores or carbonate ores. Clear, everybody? Next, copper and silver also you can take it, or mercury also. So copper is a less reactive metal found in basically copper sulfide, like we can take it as a sulfide ores, including the silver also. Next, platinum and gold, they are the least reactive metals found in the elemental form. That elemental form only we used to call as something. Anybody? Elemental form is called as something. What is that? Yes, please. The word I used many times. Native metals. Native metals means they will be existed in the pure form. So that is what you have to remember. If you take your textbook also, you'll be arguing again in this. You'll be having. You can notice it, all of you. So there will be a tabular column like metal activity series. Activity series and related to metallurgy. This is most important one. So sodium, all of you check it here. So sodium, potassium, calcium, magnesium, and aluminum. All are what? Actually, more reactive or less reactive? Everybody.
More reactive.
More reactive. So that is why for them they are always present in combined state. So for extraction process, we undergoes what? The metals top or the top of the activity series are so reactive, so they never found in nature as a free elements. Always they will present in what state? Everybody. They will present in combined state. Understanding? So they are the metals middle. What is the metals? Zinc. Next what? Iron, lead, and copper. These are moderately middle of the activity series, are moderately reactive. So they found in the earth crust mainly as a what? Everybody. They found in the earth crust mainly as a oxide ores, sulfide ores, and as well as carbonate ores. And these they will found in a they found in a what? Basically, they found in a what? All of you. Yes, please. These all found in a what state? Just now I said they will be present in oxide forms and or halide forms. Halide ores. That is what all highly reactive metals, oxides or halides. These middle moderately reactive metals, oxides, sulfides, and carbonates. And you can find copper and silver. You can notice it. Of course, copper is moderately and silver. So they are found in a combined state as their sulfides or oxide ores. So copper and silver, they will be present in what state? Sulfur or? Yes, please respond. They will be present in either sulfide ores or oxide ores. That is what copper, what is the source? Tell me, anybody? Look into your tabular column and tell me, what is the source of copper? Copper sulfide or copper oxide? Am I right or wrong? Copper sulfide only we used to call copper glance. Check your notebooks, tabular column. All of you.
Yes, sir.
Yes.
Yes, sir.
That is one. So copper and silver is present. Basically, here you can see that is present in sulfide or oxide ores. Next, last, of course, silver is least reactive. Platinum is not included in our textbook activity series, so you can avoid platinum. So silver and gold mainly is found in native state. So native state means only we can call, just now I said, what is that? Elemental form. Understanding?
Elemental.
That is what least reactive. Now, here reduction, these metals, zinc, iron, lead, and copper, reduction using carbon. So carbon means what? We are using a what here? Coke. Understanding? Coke or coal, both we can use it as a carbon. Because coke and coal are in the form of what? Everybody. Carbon only. Understanding, Amma? Please respond, all of you. So that is what it is. Now, this will be explained the entire steps involved in the extraction of metals from ores. We should remember this, then only we can go further. According to this only, we all people will go extraction of metals. So let us make it that. So highly reactive metal C, very simple process. What is the highly reactive metals process? Everybody read. Just we'll go with the what? Electrolysis of ore, directly we'll get the what? Directly we'll get the pure metal. Understanding? Please remember that in highly reactive metal, simple process undergoes electrolysis, directly will obtain the pure metal. Am I right or wrong? Everybody? Yes. And metals, low reactivity. Just it may be sulfide ores. Low reactivities, that's what we have written here. Like a low reactivity. Who is that? Silver, copper, this all you can take. Sulfide ores. So they are just if they are sulfide ores, you have to undergo what? Roasting process. Yesterday I have taught you roasting means what? In the presence of oxygen or absence of oxygen? Everybody. Presence of oxygen. Understanding? Calcination means what? Calcination means
Absence of oxygen.
absence of oxygen. Absence of oxygen. That is what. So if it is metals of low reactivity, I will give you the examples. If they are sulfide ores, directly go for roasting. Roasting means it will be converted into oxide ore, so that you will get the metal. Metal directly will go with the refining. If it is metals mediumly reactivity, this is only big problem. What is the metals? Zinc, iron, and lead, and as well as copper. Moderately reactive metals. So here we have to use oxidizing agent. What is that? Sorry, reducing agent. What is the reducing agent, guys? Carbon.
Carbon.
This is what? Coke or carbon. So here, if it is a carbonate ore, we undergo the calcination process. If it is a sulfide ore, we undergo the what? Everybody? Roasting. See, whenever keep it in mind, if it is a sulfide ore, you have to go under what? Everybody. You have to go under roasting. Understanding, Amma? If it is a carbonate ore, you should go under what? Calcination. So both the process, finally they will make oxide of metal. So oxide of metal by using a reduction to metal. By using what we will use? Reduction. Here we will use something. What is that, guys? Yes, please. By reduction process, what we will use? Coke. That is what we can say carbon. For reduction process only we will use it. Am I right or wrong, guys? Then we will put the
Yes.
okay. So this is what the steps involving in extraction of highly reactive, low reactive, and moderately reactive or medium reactive metals of moderately reactivity. So moderately reactivity only is a big like we can say big number of more number of equations and more number of steps will come. But without this flow chart, you people cannot able to answer the questions which are going to come in this from this concept. Okay, so let's start now. Let us start with the extraction of metals low in the activity series. So I'll take two examples. So extraction of metals low in the activity series. Let me take the copper and mercury and I'll proceed it. So copper and mercury metals generally existed in the form of what? Check your tabular column and tell me. Copper and mercury both are existed. Yes, please. Both are existed. What? Yes. Speak loudly, guys. What they are existed? They are existed in the form of what? Sulfide ores. So we have to undergo the what process? Low reactivity. Yes, we have to go under what? Just now I said.
Roasting.
Low reactive means you have to go under what? Roasting process. Am I right or wrong? All of you? Please respond. That is what. So keep adding extraction of metal low in the activity series. So what is the example? Whenever they ask you low, you have to make two examples. Your NCERT book also will be there. So one is copper, next one is mercury, Hg. So extraction of metals low in the activity series. Is it okay? So what are the examples? Copper and all of you. Copper and mercury. Okay. So first, basically they will exist in the form of what? Check it, everybody. Copper and silver, mercury, both existed in the form of what? All of you.
Sulfide.
Yes. In the form of sulfide ores. So whenever you speak about sulfide ores, immediately your mind should say you have to do some process. What is that? Mr. Sanjay Kannan? Yes, Mr. Rohit, Nimish. Speak loudly. What you have to do it, guys?
Roasting process.
Roasting, sir.
What I'm asking. Understanding? So let us follow it and make it. So remember, first concentration of the ore we have to do it. Am I right or wrong, guys? Yes. So just remember, these metals, they can be obtained from its ore by just heating alone. So heating alone is sufficient to obtain the pure metal. So first process, step one. What is the step one? Concentration of the ore. So concentration of ores, if you have taken, so these sulfide ores, as they are sulfide, so sulfide ores are concentrated by some method. I have already taught you. Can you tell me? Sulfides are concentrated by using some method. Anybody? Fourth flotation. What is the process is not, even this statement is also not required for you. So just remember that. So sulfide ores can be concentrated by the method called as fourth flotation process. Step two, if it is a sulfide ore, immediately we have to undergo what, guys? Fastly, everybody. We have to undergo roasting. and as well as next step, we have to undergo reduction process. So let us see now first, all of you. So the sulfide ores are heated in open air. They will get converted into oxides. So roasting means heating up open air or close, everybody. Without oxygen or with oxygen? Everyone.
With oxygen.
Without oxygen. So heating in open air, then get converted into oxide. So that's all we have to do it. So, and if you converted continuously, if you continue the heating, then they will converting into what? If you continue the heating, they'll be converting into. Yes, Ra, check your notebook. If you continue heating, what will happen? They'll be converting into pure metal. Am I right or wrong?
Yes, sir.
Yes, the oxides get converted into metals. That's all it is. So that is why these metals, simply on heating alone, we will obtain the pure metals. So first, mercury. What is the, anybody can tell me what is the common name of mercury ore? I want to know. Let me see. What is the common name of mercury ore? Fastly. Cinnabar, and the name is mercury sulfide. So let us see how we can beat. So everybody read. Mercury sulfide will react with oxygen. Yesterday also we have done. So undergoes heating. So roasting means presence of oxygen. So what is the products will come? We'll get mercuric oxide plus we'll get sulfur dioxide. Am I right or wrong, guys? So this process is only we used to called as what? What we used to call roasting. Now, if you continue the heating further, further, so what will happen? Everybody, you should speak. You will get mercury plus oxygen. So oxygen is removed. So that what process we used to call as reduction. Okay. So that's all it is. So balance it and tell me what is that. Everybody has to balance it. So I already given a clue. Mercury Cinnabar. This is Cinnabar. So balance it, everybody. Equations don't know, no use of studying chemistry. You have to work with the equations. That is the reason you have to practice each and every equation many times. Balancing equation you all need to know. Without balancing equation, there is no use of studying. So 2GHO. So here we will get 2Hg and we will get O2. That's all. So this is what mercury extraction process. Roasting followed by reduction. Okay. All of you clear? Yes, Mr. Hare Krishna, Aswin, Gokul, Aswin. Not working also don't know. You unless you write and make, you cannot. Mr. Johan, are you writing the classwork? I want to see. Make it fast. So next, sulfide ore. Can you tell me copper sulfide ore name, common name? Copper sulfide, common name. Copper sulfide ore, copper name. Common name, guys. Yes.
Copper glands.
Yes. We used to call it as copper glands. So copper glands formula, tell me. Copper glands formula. Cu2s. Okay. So that's all it is. So Cu2s, which is in solid state, reacting with the gas, burning. That is what roasting process. In the presence of oxygen, open air, we will get copper oxide. Okay. This is only we can say cuprous oxide. Cuprous oxide, ROUS, learn it. Cuprous oxide plus SO2, sulfur dioxide. So this process only we used to call as what? Everybody. We used to call as roasting. Am I right, everybody? Please respond. Then we have to take that cuprous oxide and then further if you continue, keep it in mind. Further you continue, here equation will change little. Again, cuprous oxide plus cuprous sulfide, if you take it, and then if you are heating, continue the heating, then we will get copper plus sulfur dioxide. Okay, so this is the process we used to call as. What is the process we used to say here? Reduction. So balance it, anybody? Balance these equations, please, all of you. Balance these equations. Nobody. What is that? Balance these equations. 2CuS 3, and here we'll get to 2CuO2 plus 2SO2. Again, keep it in mind, mercury directly, mercury oxide will undergoes. But for copper, again, cuprous oxide and cuprous sulfide is also reacting. So then only you will get pure copper. That is what, please remember that. Okay. So balance this equation, everybody. These two equations for mercury and as well as copper, extremely important. So please learn, everybody, roasting and as well as reduction process. So this is what is about extraction of low reactive, extraction of metals low in the activity series. You should remember two examples. One is copper, another one is what, everybody?
Mercury.
Mercury. Very, very important one. Please make it. So now this copper obtained can be refined. Refining by the what process? Anybody? I already told you in 10th class only we will use one process for refining. What is the process we will use? Electrolysis process. So once you obtain the pure that copper, still it is having impurities. So that purifying, that is what is the process called as electrolytic refining of copper. Means already we got the copper. Again from the copper, you have to remove the further impurities to obtain the pure copper. So for that only, electrolytic refining of copper will use it. So here, what is the electrolyte? Everybody read. The electrolyte is a what? Solution of acidified copper sulfate. Solution of acidified copper sulfate is the electrolyte. Acidified copper sulfate. What is the formula of copper sulfate? Anybody can tell? Copper sulfate, USO4. Acidified copper sulfate. So it is a good conductor of electricity or bad conductor of electricity? Good conductor of electricity. And always keep it in mind, the impure metal block is taken as anode. So anode must be taken as a what? Impure one or pure one? Everybody. Impure metal. And cathode, always I told you, you will get a pure metal at what? You will get a pure metal at where, guys? At a cathode. So, and connected with the positive terminal. See, anode must be connected with the positive terminal. And here we have taken impure metal or pure metal? Everybody. Impure copper. Impure metal, that is what? Copper. Impure copper has been taken as anode. And pure copper has taken as a what? Pure copper has taken as a what? Everybody. Respond. Yeah. Pure copper is taken as cathode. Understanding? And what is the electrolyte, everybody? What is the electrolyte? Acidified copper sulfate. So, if you undergoes chemical reaction, if you pass the electricity here, all of you observe what is happening. The impure copper metal, you can see what is the aqueous solution of copper sulfate acidified with basically dilute sulfuric acid. So that acidified means we have added sulfuric acid so that it will converting into good electrolyte. It will convert electricity, it will conduct the electricity more properly. So then what will happen? Anodic reaction and cathodic reaction. So anodic reaction will take place. Can you tell me at anode what will happen, guys? Fastly. Forget about this one. You tell me this. For aluminum is obtained by electrolytic reduction. Okay, that all the things we will get from the same thing only. I want anodic and cathodic reactions here. Anybody can tell me? Copper. Electrolysis process. See, electrolytic refining only many metals such as copper, zinc, tin, nickel, silver, gold, all refined by electrolytically. So in this process, impure metal is made the anode and a thin strip of pure metal is made up of cathode. Now you tell me, when the process is going on, anode size will decreases or increases, or cathode size will decreases or increases? That is what my question to you people. Anybody? If the electrolysis process is going on. Yes, please. See, they are taking as a cathode as a very thin strip, so that after the process, the cathode will become more thicker or more thinner. Anybody?
Thicker.
More thicker. See, from here, the mud, the anode mud, the impurities are separating and copper atoms are going and attaching to it. So going and attaching, going and attaching, going and attaching. So cathode thickness will increases or decreases? Everybody. Cathode thickness increases and anode thickness will decreases. So that is what. So a solution of metal salt is used as an electrolyte. What is the metal salt we are using? If it is a copper extraction, we will use what is the metal salt? Everybody. Copper sulfate solution, acidified copper sulfate solution. Understanding, Amma? So on passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. So the soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode. That impurities only we used to call something insoluble impurities. What is that called as? Everybody. Insoluble. Insoluble impurities only we used to call as anode mud. All of you remember, from the anode, the copper will dissolve in the electrolyte and it will be going towards to the cathode. So that is why the thickness of the cathode increases and the thickness of the anode keep on. Everybody, keep on decreases. Now I want anode and cathode reactions. Can anybody tell me? See that various process, they are not very pure. You undergoes refining only. Last step number 4 is only will get a pure metal. So electrolytic refining. To obtain the pure metal, what is the process we'll follow, guys? Widely used process, electrolytic refining. Of course, many processes is there, but class 10th we have only this process. I want cathodic and anodic reaction. Anybody? Let me see. Who will say? All of you. Anodic reaction. Anodic reaction. Harish? Cathode. Yes, please. All of you should respond. Just a minute. Yeah, you tell me. Yeah, tell me anodic reaction, please. Anybody? Anodic reaction. Anodic reaction, what is there? Copper is pure copper will dissolve so that it will lose the electrons. So how many electrons it can lose, guys? Everybody? 2 electrons it can lose. And these copper ions will go towards to the what?